Okay, so now we're going to do the SOA number 132. And in this problem, we have that the number of claims is a Poisson with lambda equals 2, and the severity of these claims is a Pareto with theta equals 500 and alpha equals 2. And the simulated values they gave us for the Poisson is 0.8, and the ones for the severity are listed here. So starting off, we're going to build the CDF for the Poisson distribution. And you know from our tables that P of K for a Poisson is equal to e to the negative lambda, lambda to the K, over K with the exclamation mark. And so for values of x, 0, 1, 2, and 3, our f of x, plugging into this equation, or plugging x as the K into this equation will get you 0.135, 0.271, 0.271, and 0.180. So from here, building the cumulative distribution, you just add everything that's above this. So in this case, it's just 0.135. Here, you add these two together, and you get 0.406. Here, adding this one and this one together, you get 0.677. And here, adding all of these, or this one and this one together, you get 0.857. So now you have your simulated value of 0.8, which is right in between this. So you know that this means that you had 3 claims in your simulation for this year. So knowing that n is equal to 3, you are going to take the Pareto function for your severity. And you know from our beautiful tables that the cumulative distribution of a Pareto with theta equals 500, alpha equals 2 is equal to 1 minus 500 over the quantity x plus 500, and this entire thing to the alpha, so in this case 2. And this is equal to u as per the inversion method. So now doing basic algebra to solve for x, you're going to have 1 minus u is equal to 500 over x plus 500 quantity squared. So taking the square root of both of these, you have 1 minus u to the half power is equal to 500 over x plus 500. Multiplying this to this side, you're going to get, okay, so multiplying this to this side and dividing this to this side, you get x plus 500 is equal to 500 divided by 1 minus u to the 1/2. And solving for x again, x is equal to 500 times 1 minus u to the negative 1/2 power minus 500. So here you have your inversion method. Plugging these simulated values into this equation is going to get you 0.6, or 0.6 gets you 290.57. 0.25 gets you 77.35, and 0.7 gets you 412.87. And the reason that we only take the first 3 simulated values, even though we are given 5, is because we know that n is equal to 3. So it doesn't really make a lot of sense that if you only have 3 claims, why would you simulate 5 of them? And so taking the total of this, you actually get your final answer to be 780.79. However, this is not the end because we're asked what the premium is, and you know that the premium is calculated as 750, 80% of that. So you pay 80% of the first 750 in claims, plus 100% of anything in excess of 750. So 780.79 minus 750. And this gets you your final answer, which is 631. And that's it. Okay, so now we're going to move on to SOA number 182, and in this question we have that there are 100 people aged 65, and the probability of death for these 100 people is 0.03, which makes this a binomial distribution with m equal to 100 and q equals to 0.03. So from this, we obviously know that p is equal to 0.97, since p and q have to add up to 1. So looking at our tables, we know that the equation for p sub k for a binomial distribution is as follows. And so having this, we can calculate the probability of having 1 death, or 0 deaths, 1 death, and 2 deaths. And so from here we know the equation is 0.97 to the 100th power, just plugging 0 into here. And this one is equal to 100 times 0.97 to the 99 power times 0.03. And this one is equal to 100 times 99 divided by 2 times 0.97 to the 98th power times 0.03 squared. So plugging all of this into our calculators, we get the following values. We have 0.04755, 0.14707, and finally 0.22515. However, these are our little f of x's, and what we really need is the cumulative distribution function. So in order to get that, we basically just add everything above it. So in this case, the cumulative for f of x of 0, sorry about the smudge, is equal to 0.04755. And then the cumulative for 1 is equal to this plus this, which is 0.19462. And then big F of 2 is equal to this plus this plus this, which gets you 0.41977. So these are your cumulatives. And from this, you can use the feed in your pseudo random sequence, and you get that 0.2 goes right here, which correlates to 2 claims, and then, or 2 deaths, I guess. And then 0.03 goes above here, so this one is 0 deaths. And then 0.09 goes in between here, so this one is 1 death. So taking the average of these numbers, we get the mean number of deaths is equal to 1. And that's it. Okay, so now we're going to go to SOA number 122. And in this problem, we have that the number of claims is distributed with a binomial distribution with m is equal to 3. And we're not given what q is, but we are told that the mean is 1.8. So we know the mean, so 1.8 should be equal to m times q, and we know that m is a 3, which means that q has to be 0.6. So filling that in here, we have a binomial distribution, m equals 3, q equals 0.6. From our tables, we know that p of k for a binomial is equal to this beautiful equation right here. And using this equation, we can build our CDF chart. And so with x is equal to 1, 2, or 0, 1, 2, and 3, we know that f of x, which is this equation right here, plugging everything in, we get 0.064, 0.288, 0.432, and 0.216. But this is only little x, or little f of x. And what we want is the cumulative, so big F of x. And the way to get this is to add everything above it. So in this case, this is just regular 0.064. But here you add these two together and you get 0.352. And here adding these 3 together, or these 2 together, you get 0.784. And finally, you get 0.1. So from here, we can start simulating the number of claims with our pseudo-random sequence, which is 0.7, 0.1, 0.3, 0.1, 0.9, 0.5, 0.5, 0.7, 0.3, 0.1. Now this problem is weird in the sense that they gave you a pseudo-random sequence, but they didn't give you two separate ones, one for your claims and one for your severity of those claims. So you kind of just have to alternate between them. So if you take this first one, you're going to apply this to the number of claims. So 0.7 in this chart goes right here, which means that correlates to 2. So you know in your first year you had 2 claims, which means that the values of 0.1 and 0.3 in our sequence, the 2 immediately following the 0.7, these are going to be used to calculate the amount. And next, so now you've used these 2, you can't use them again. You're going to look at this one, 0.1, and you know that 0.1 is between this and this. So in the second year, you only had one claim. That means that 0.9 is going to be used to simulate the severity of this one claim. And then the next number you can use is 0.5. 0.5 is again in between these, so it's going to be another 2. And so these 2 are going to go with the severities of this third number of claims for the third year. So here's 0.5 and 0.7, and then lastly we have 0.3, which is right here, so that means there was one claim, and perfectly we have, one extra pseudo-random sequence number to use to simulate the amount for this. Now the question asks, what is the amount of claims in the third year? So you're only concerned with this, so we don't really care about any of this. And so we have 0.5 and 0.7. We're given that it is a uniform distribution for the severity, and the only values you can have are 1, 2, 3, 4, and 5. So that means that f of x, big F of x, is equal to 0.2x. So we know the first value is 0.5. So this is between 0.4 and 0.6. Or I should write it this way. So 0 to 0.2, 0.2 to 0.4. So this corresponds to 1, 2, 3, and then 0.6 to 0.8 is 4, and then 0.8 to 1 is 5, because of the cumulative of a uniform. And so your first value is 0.5, which is here, so you have 3 for your first severity. Then your next value is 0.7, which is here, so you have 4. And summing these 2 together, you get your final answer, which is 7. And that is your total amount of claims.